Hello there. This is Cody Jackson for Cody, and we are continuing our discussion of the Python data types. You're probably tired of me talking about this now, but I never know which video somebody's going to be starting with. So the Learn Programming in Python book is where a lot of this information is coming from. And then the other book is Secret Recipes of the Python Ninja, which we'll be talking about after we get through the Learn Programming. Those are both available on Amazon, and yes, I am the author of both of those. So that's enough of the blatant plug. Let's move on. So we are going to talk about lists and tuples today. Lists and tuples are sequences of objects. In Python, everything is an object. So you can have a list of lists, you can have a list of tuples, you can have a tuple of lists, whatever the case may be. They can be integers, you can have strings, all of that stuff. I'm putting lists and tuples together in the same category because they are effectively the same thing. The only difference is lists can be modified, tuples cannot be modified. So let's start with lists. Lists are probably one of the most commonly used data structures within Python. It's just a sequential array of objects, like I said. If you remember from the string video, a string is basically just a specialized type of list. So again, lists start with an index position of 0. Rather than only holding text, they can hold anything, so numbers, integers, other lists, dictionaries, pretty much anything, really. Lists are variable in length. They are mutable, meaning you can change them in place. You can add, remove items from a list, and a new list is not created. It modifies that particular list that you're working with. You can identify a list because it is surrounded by square brackets. So if you have an empty list, or if you have only a single item in your list, it just has to be surrounded by square brackets, and Python knows that that means it's a list object. As I mentioned, tuples are similar to lists, except you cannot modify them. You have to make a new tuple if you want to make any sort of changes to it. This is good because if you have a sequence of objects that you don't want either purposely or accidentally modified, then put it into a tuple, and Python will not be able to modify that tuple without you creating a copy of it first. They are not commonly used by developers directly within their programs unless there's some sort of a data structure that they want to be not modified, obviously. Commonly, what you would have is a list would be homogeneous data values, so everything is similar, so you can perform the same operation on each one. So maybe a list of names or something like that. A tuple might be heterogeneous data, so it might be point of contact information, so a name, address, phone number, and that would be one object within a tuple, and then your next object would be the next person, and so on and so forth. But you don't want people changing those because that will mess up your data, and so you would put it into a tuple. On the other hand, tuple unpacking is very common to do because what you can do is return a data value from a function, and that can be packed into a tuple, meaning you receive a single tuple, a single object from the function, but it is comprised of multiple objects within it. We'll show an example later which explains this in better detail. Talking about it doesn't probably make a lot of sense. The primary difference between lists and tuples is that tuples are surrounded by parentheses, lists are surrounded by square brackets. Now, I do need to note, tuples are not always surrounded by parentheses. They do have their objects separated by commas, but then so do lists. So don't always expect tuples to be surrounded by parentheses, but always expect lists to be surrounded by square brackets. As sequences, similar to strings, They also have the same functionality as strings do. Tuples, because they cannot be modified in place, have a lot of those same functions, but they do not have anything that would allow you to modify a tuple. So you cannot append to it, you can't extend it, things like that. The most common operation to perform over a list of objects is some iteration over that sequence and performing the same action in each one. That may be printing out each value, it may be adding a list of numbers to other numbers, whatever the case may be. Within a list, because it is mutable, you can use the .append method to add additional objects to the list, and those are added at the end. Or if you have a specific location you want to insert an object into that list, then you can use the insert method with the index of where that item is going to go and then the value for what that item is supposed to be. You can combine lists by using the .extend method. So that's a little bit different than appending, whereas appending is adding new objects to an existing list. Extend combines lists together. And then finally, we're going to talk about the sequence unpacking on tuples. So if we assign a tuple to a sequence of 1, 2, 3, that's a single object, the surrounded by the parentheses. So from that single tuple object, you can extract each of the values that are contained within it, and in this case, you would assign them to string variables. So the text string of 1 would equal the integer of 1, text string of 2 would equal integer of 2, and so on. And so you can do that for anything that's packed within a tuple. So that is a common thing to do, either from built-in return functions, giving you back a tuple to work with, or if you want to have multiple objects returned from a function, then you could do that yourself. This is kind of different from other languages where you can only return one thing and they don't have a data structure like a tuple. So if you wanted to return multiple objects, you would have to have multiple functions returning each part of that. So we are going to jump over into our IPython environment, and we're going to interact with some of these data structures so you can see what it is that I'm actually talking about. In this case, I've just created a simple list, list 1, and you can see that the list is surrounded by square brackets, and that tells Python that this is a list. If we want to list the items that are present, you have the option of just calling the list itself, and it spits it back out as a list. Or you can print the list, and it does the same thing. And you can see that it gives you the outline if you call it as is in number 2, and in line 3, if you print the list, it doesn't give you the output line. It just gives you the output. So I had talked about how iteration over a list is probably the most common thing to do. So in this case, we will do that for this list, and you'll see how iteration over a sequence within a list can work. So in this case, in line 4, all I did was start the sequence, and so this is just a for loop. We haven't talked about loops yet, but this is getting into that. So for number within list 1, go ahead and print that number times 2. And then you can see that it's gone down in a row and it's multiplied each one of those by 2. Now I should note that the variable name that I used here, num, that can be anything. I can do the exact same thing again and just say for x in list 1, give me x times 2. And it does the exact same thing. In this case, Python does not care what the variable name is that you use for a iteration type sequence. If you want to call a specific item from the list, then you give it the list name, the variable name, and then the index position. And in this case, because we started out with an index position of 0. So the third index position is going to be the fourth item in the list, and so it gives us 4 as the output. If you want to pop out the last item, and so this is an actual method, so list1.pop, and then you call it, and now it has popped out the last item. If we print the list again, now you'll see when it pops, the last item in the list is returned to you and removed from that original list object. So in this case, it has returned the value 4, and then the list now has 3 objects in it. And so this is common to do if you have some sort of a data stack of information that's coming in, and you keep pushing down on that stack. Think of a plate holder at a restaurant where you pull the top plate off of that plate stack. What you're doing is you're popping the last item from the list off of that and removing it to do something with it and leaving the rest of that list there. I said that we can append to it. So if we want to append, then we can add the value, let's say 7. And then we print the list again. You'll see when we do the dot append and we add the value 7, it puts it at the end position of that list. And if we want to insert a value, then we just have to tell it the position and the value. So in this case, we're going to insert the value 10 and position index number 2. So starting with 0, the second value, 0, 1, 2, is going to be the third position, and so the value of 10 is put into index position 2, or counting from 1, the third position within that list. So if we wanted to extend, which means concatenate 2 lists together, we already have list 1, which is a list of numbers, and I just created list 2, which is a list of strings. And so we would just basically extend to list 1 with list 2. And so if we print list 1 again, you see that list 1 has now been changed, and it's added all of the objects that were in list 2 are now part of list 1. So it's similar to appending, but it basically takes an entire sequence and dumps it in at once rather than individually using the append. Something that you need to get familiar with is list comprehensions. They have been in Python for a very long time. When I first encountered them, they really threw me for a loop. And so I will show you what a list comprehension looks like, explain the parts of it, and then we will execute it to see what it's actually doing. So in this for loop, we are just taking each of the individual items within the list, list 1, and basically just printing them to the screen. So we can do the same thing using the list comprehension. It's a little bit shorter, it's very compact actually, and it does the same thing, but it actually returns a list object rather than individual values. We already have the for loop in here. For value in list 1 right here is the exact same as our for loop up here, for value in list 1. And then it's basically saying return the value, so the individual items, exact same as we have here, so print value. In this case, it is returning the entire object, the list object, but it's iterating through each of those values within the list. Often what will happen is you will have a list comprehension and execute it as an assignment to a variable name. So in this case, I just took the list comprehension, assigned it to a variable called new value. We execute new value, and it gives us the exact same list that we had in list 1. You can also make changes to the environment as you execute the list comprehension. So in this case, I just made a new list, a list of text strings, and for the list comprehension, this part here is what we've seen before. This is just the for loop and then returning the values within the list, but we are adding it to another text string so that the output is actually the text string that we've assigned it here, number, with the individual values from the list. And so we've basically created an entirely new list just by one command, a list comprehension. So same with text strings, we can slice a list. So if we call back our list 1 and we want to slice from item 2 to item 5, then we put that within square brackets separated by a colon, and it gives us the items that are in list 1, position 3 through position 6, or index value 2 to index value 5. I know that doesn't make a lot of sense again, but if we pull it up here, index 0, index 1, index 2, 10, index 3, index 4, and then index position 5 is not included. So again, we saw this in the text strings video. The first value is inclusive, so that is going to be included in the output. The last value is exclusive, so it is not included in the output. If you want to delete a value, you can do that. So it's basically similar to pop, except you're not capturing the output, you're just deleting the value. And it can be any position within the list, it doesn't have to be the last item. So if we want to delete, say the number 10. So remember to use the correct brackets when you're working with these things. Generally speaking in Python, parentheses, apart from tuples, are only used for functions, classes, and things like that. Otherwise, if you want to access individual elements within an object, it's going to be square brackets. So we've deleted position number 2, or the number 10, and so if we print the list again, you'll see that number 10 has been removed. It hasn't been returned to us like a pop, it's actually just dumped out of there. So we're going to move over and take a look at tuples really quick. Like I said, they are basically the same as lists, except they cannot be modified. So if I've created a tuple here, just a sequence of integers, and I try to run the append like we did for the list, we're going to get an error saying tuple object has no attribute appends. Basically, it just means you cannot append to a tuple because it doesn't know what that means. It's not capable of doing it. So we had talked about sequence unpacking. So we have our tuple here, which is just a sequence of numbers, and we want to unpack each one of those from the tuple object to a variable of its own. What we've done is we have told Python that we want to extract each one of those items from the tuple to its own separate variable given the names that we have here. So first has the number 1 associated with it. Second has the number 2. Third is the number 3. And fourth is the number 4. And so if we call tup1 again, the tuple is still there. The tuple hasn't gone away. We've just extracted each of the items from that tuple and given them their own unique variables so that you can work with those items within the tuple by themselves, or you can work with the tuple itself as a complete data structure and do whatever sequence methodology that you want with it. And I said that you can also create a tuple without parentheses. And so if I print tup2, you see that it's still a tuple. It knows that it's a tuple. It puts the parentheses on there, but we didn't have to indicate that because it knows that due to the commas. So if we wanted to make a third tuple, but that it's only a single object, all we have to do is put the value and a comma, And Python knows that we have created a tuple because of that comma there. If we didn't have the comma, then it would just be a regular integer object. So when you're working with tuples, I recommend to use parentheses just to make it blatantly obvious that this is a tuple object. Having the commas in there without any other identifiers such as the square brackets or anything like that, yes, that makes a tuple, but if you're glancing over the code or anything like that, it may not be immediately obvious that that is what that is until you print it out and you see that it is surrounded by the parentheses that the Python interpreter has given to it. So before we move out of here, I just want to talk briefly about some other benefits of using tuples versus other data structures. So tuples are processed faster than lists. This is because they're not mutable, so Python doesn't have to take into account any potential changes that have happened to the tuple. So if you need to create a constant set of values that are not going to change, and you're only going to be iterating through them, it's actually quicker for you to make a tuple than it is to create a list. Because tuples cannot be modified, they are very useful for allowing external users to access your program through an API. An API is an application programming interface. Basically, that just means your program is a black box, and for the user, all they need to know is what goes in and what comes out. And for you, as the developer, you can create whatever data structures you want, but if you want to allow the user to work with your data without changing it and potentially breaking something, you can kind of protect that data by returning it as a tuple, and then they cannot modify it. And so that's about it for tuples. Let's move on to the next discussion topic, which happens to be dictionaries. So dictionaries are also very common in Python programs. Dictionaries, rather than just being a sequence of objects, is a sequence of keywords with a value associated with it. So you're mapping a key to a value, and to extract that value, all you need to know is the key. You don't need to know the index position or anything like that. Dictionaries can hold any type of object and any number of objects, similar to a list. The only caveat is your key has to be a hashable object, which means it cannot be mutable. So a key can be an integer, it can be a text string, it can be a tuple if you want. Pretty much anything that is not going to be modified can be used as a key. It supports deep nesting, which means you can have a dictionary within a dictionary within a dictionary, so on and so forth. As you add new dictionaries to it, you change it from a single row to a tabular data to a three-dimensional table, so length, width, and then also vertical height. So if you have a dictionary within a dictionary, at that point you have a very crude but quick processing table or database even. Dictionaries, because they are not a true sequence, have their own methods, their own functions, and they work differently from other sequence data types such as lists. So we've jumped over into our IPython, and I've created a dictionary. So each one of these text strings that you see up here, 1, 2, and 3, are all the keys. And the values are designated by the colon and then the value itself. So 1 has the number 1, 2 has the number 2, and 3 has the number 3. So basically what we're doing is we are saying this integer is mapped to this text string. If we want to get the length of the dictionary, then we can call that and find out how many key value pairs there are within the dictionary. There's 3. If we want to get the value for keyword 2, so you give it the key, in this case the text string 2, within square brackets, again, remember, if you're calling individual items, you're going to use square brackets. If you're making function calls or anything like that, then they're going to be parentheses. And in this case, we get the value back, the integer value 2. If you want to add a new mapping to the dictionary, you again use the square value or square brackets with the key inside it, and then you have the equals whatever value you want to assign to it. So if we print dictionary 1 again, you'll see we have 1, 2, 3. Chicken has the number 3 associated with it. So you can use any combination of things you want. It doesn't have to make logical sense. Now, something that's interesting is you can perform some operations directly within a dictionary. So if we want to increment the value that's associated with the key chicken, we can do plus equals, which basically says add this and then give us the result in place of that value. So take the 3, add 1 to it, and then return that result to that position. So if we print it again, you'll see that the number 4 is now in the value for chicken, whereas 3 was the value before. So you can perform some operations depending on what your values are within the dictionary without actually pulling it out and doing your operation outside of the dictionary. Now, there are many methods associated with the dictionaries, just as there are with sequences. We're not going to go into all of them in these videos, but I'm going to touch on some of them just so you can kind of get an idea of how they can be used. So if we want to see, is the keyword chicken in dictionary 1, then we can actually ask, does chicken exist in dictionary 1? And it will say either true or false. If we want to get all of the key value pairs from the dictionary, then we use the word items. And so it returns to us a object showing each of the key value mappings that are within the dictionary. And it's returned as a list rather than dictionary items. So if you need a quick and easy way to convert a dictionary to a list for whatever processing you're doing, then it will return your dictionary items as a list. So you have the square brackets on either end, and then within that, the actual mappings are tuples. So you have your key and the value, but that is a single tuple. Your next mapping is another tuple, and so you basically have a list of tuples. But everything is in a sequence, and so you can use a lot of those sequence methods to work with them if you need to. If you just need the keys out of the dictionary, then you can extract just the keys. If you need just the values out of the dictionary, you can do that too. Now notice both times it returned it to us as a list. So again, if you need a way to convert a dictionary to a list, you don't have to do a lot of jumping through hoops and creating your own functionality to do that. You can either extract the key value pairs as items, you can extract just the keys, or you can extract just the values. And if you want to delete objects from the dictionary, you can do that as well. So we've deleted the key chicken, and because it's already mapped to a value, it's deleted that value associated with chicken as well. So when we print dictionary 1 again after the deletion, you see that the key value pair of chicken 4 has gone away. So that's it for dictionaries. We are going to jump back into the presentation and talk about sets. So sets look similar to dictionaries in that they use curly braces. I forgot to mention that when I talked about dictionaries, but lists use square brackets, tuples use parentheses, dictionaries use curly braces to denote that is a dictionary. Sets use curly braces as well, but they do not have key value pairing. They only have values. Sets are most commonly used to take a data set, a list of items or whatever, and automatically remove duplicate values quickly check whether a data collection has a particular value you're looking for, and then there's also some mathematical operations that you can perform on that data. They do work as a sequence in terms of providing functionality like lists and strings, but because they do provide mathematical operations, there are obviously some set-specific functionality as well. So I'm not going to talk about the sequence functionality of sets. You've seen lists, you've seen strings. While I may not have covered all of the methods that are available with those, you'll see them as we go along, and as well as being able to look at them in the documentation online. So what we're going to talk about for sets is some of those mathematical operations that we were talking about. So first we're going to create two sets. Again, notice that they use curly braces like dictionaries, but there's no key value mappings in there. First one we're going to talk about is the isDisjoint function. So this will return the value true if set 1 has no elements that are in common with set 2. In this case, set 2 is just a single word, broccoli, and set 1 is a bunch of other words, but there's nothing in common between those two sets. And so it's coming back and it says true, meaning that there is no commonality between set 1 and set 2. If we say set 1 dot union set 2, then it takes set 2 and adds it to set 1, creating a new set. As you can see, we have broccoli, chicken, eggs, ham, spam. So pretty much like appending or concatenation of other sequences, we're doing the same thing, except we're just kind of joining them together. If we use intersection, so set 1 dot intersection set 2, what that does is it creates a new set that has all the common elements between the two sets. So if we go ahead and we modify set 2 to have something in common with set 1, in this case, the only thing that's common between those two sets is the word spam, and so that's what it returns to us. If we use difference, then it returns everything that is not in common between the two, while also being unique to set 1. So spam is common between the two, so that's eliminated. Broccoli is only in set 2, but difference primarily only cares what is unique and not common for set 1. So basically it's going to return set 1 minus anything that's common with set 2. If we use symmetric difference, then it goes ahead and includes everything that is unique to each set. So spam was common between the two, so that's eliminated. Chicken, eggs, and ham from set 1, those were unique. Broccoli was unique in set 2, and so it returns a new set that has all of those unique items. So that's it for the basic data types within Python. You now know primarily everything that you need to know in terms of what is available to you as data structures within Python. We haven't talked about loops yet. We haven't talked about conditionals, so we're still not at a point where we can really do a lot of useful programming. But at least in this case, you can create some variables, some data structures and stuff like that, and start playing around with the built-in methods that are included with them. So we did talk about sequences, lists, and tuples, what's common between them in terms of how they're sequences and how you can use them together. Tuples are used in a non-changeable aspect. They're immutable. Lists are mutable, and therefore they can be changed. We talked about dictionaries, how they differ from sequences, why they're useful, the key value mappings, how you can get a value based off of knowing what the key is, how to pull each of those parts out of a dictionary and generate a new list from that. And then we briefly looked at sets and showed how you can use them effectively with large sequence of objects from some sort of a data pull, such as database, table, whatever the case may be. You can find unique objects, you can eliminate duplicates, you can get commonalities between all of them. One thing that I didn't mention is, in our examples, we only had 2 sets, but you can actually use multiple sets within those parentheses. So if you have set 1 dot intersection set 2 comma set 3 comma set 4, you can do that, and it will go through and it will find whatever it is that you need, the duplicates, the commons, the uniques. It will give that all to you. You're not just limited to 2 sets to compare. So that's it for this video. Next time we're going to talk about namespaces and imports and why those are important to know and how to use them effectively within your programs. So until next time, enjoy yourself. I hope you enjoyed this video. Keep learning, and let us know if you have any comments, complaints, concerns, anything that you want to know. Just let us know in the comments. Thanks for watching.